Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome back to SIC1004, our physical chemistry lab. Today we're going to talk on experiment 6, which is on the determination of heat of reaction. So the objective of this experiment is to determine the heat of polymerization of acrylamide. Now, in lectures, I'm sure you have covered on heat of reaction, maybe or maybe not. But if you haven't, that's one of the topics that you will cover. And so there are many different types of heat of reactions. And one of them is actually heat of polymerization, as you will see here in this experiment. So to carry out the experiment, Dr. Faisal has shared this video to show how this experiment is being conducted, the setup and so on. So please watch the video before you actually continue with the rest of the slides. So this reaction is conducted in a Dewar flask with known heat capacity under adiabatic condition. But as you can see from the video here, that it's not really an actual Dewar flask, but this is a common, home appliance, your thermos flask, a plastic thermos flask, which is used. So you know that it's not going to be a perfect adiabatic system, but it serves the purpose of actually calculating this heat of polymerization. Just goes to show that you can actually do science with everyday tools, everyday appliances. Okay, so before you actually find the heat of polymerization, you must calibrate the Dewar flask. Okay, I'm just going to stick to saying that it's a Dewar flask, okay, although it's really not. Okay, so this so you want to standardize, you want to calibrate the Dewar flask. So this so you calibrate it by actually, when you're saying that you're calibrating the Dewar flask, you're actually calculating the heat capacity of the Dewar flask. Okay, and there are various ways to actually calibrating the Dewar flask, that is to find the heat capacity. One way is to actually carry out the reaction between strong acid, strong base neutralization, so via heat of neutralization. Okay, and so the heat of reaction is given here. So I say that one way is actually to do that, because when you go to the second year, you are going to do another way of actually calibrating the Dewar flask, that is to find the heat capacity, that is via electrically. So that's another way of you to actually find the heat capacity. But in this particular experiment, you are going to determine that via neutralization. So this polymerization is via what we call the free radical polymerization. So it involves free radicals as initiators, such as persulfate, and ferrous ions and bisulfate is used in the reaction to enhance the production of free radicals initiators. So this is an exothermic reaction, since heat is released during this formation of the polymer. So this free radical polymerization is when you have this polymer forms by this successive addition of free radicals building blocks. And so that's why it's called this free radical polymerization. And probably if you take this polymer class in the future, you will learn different types of polymerization. All right, so the way to carry out this experiment is already explained in the video, and so do watch that. So it says a calibration of the flash, so and hence you are going to do that as explained here. So once you get the heat capacity of the flash, you will then that's the number that you're going to use for finding the heat of polymerization. Now, in the actual lab, the students, when they actually do, they take, for example, one DeWalt flash to actually calibrate. So make sure that they use that the same DeWalt flash to find the heat of polymerization. It doesn't make sense for one to actually calibrate one flash but use another flash to find the heat of polymerization. So one has to use that. Okay, so you can expect that students will have different results for those who are using different DeWalt flash. Okay, so these are the method of actually doing the polymerization. So you start with the monomer and you start adding. Now you will find that in the I think in your data sheet, in the observation that you're supposed to actually look out for, but that's something that you can't do virtually. So but you can expect that from monomer to become a polymer, you can expect that the viscosity of the solution actually increases because of the polymerization. Okay, so once you have done that, so you have to plot the temperature against time and use that to actually calculate the heat of polymerization, and following this assumption. All right. So this is the table that you have to fill, but the data will be given to you. So you just process according to data that's given. So this is one example of a student's results, and so so these are the temperature before the addition, before the neutralization. Okay, and the concentration is given as such. So as soon as so it's a very fast reaction, so you can see that the jump there, and so from there you can actually find C, which is the heat of the heat capacity of the DeWalt flash. Okay, and so plot. So using this value then, so you will find the heat of polymerization. So the weight of the acrylamide, so it is plus minus, so this is the 4 decimal place, so 0.0001 plus minus. Okay, and so this is the observation. So plot the temperature against time and use this to actually calculate the heat of polymerization with the assumption that's given. Okay, so it's really good to actually also read on your physical chemistry topic on heat of reaction, so that you have a feel of this. Okay, so this is really a straightforward experiment. So all you have to do is first use the data to actually calibrate these dual flash E to find the heat capacity, and from there use that to calculate the heat of polymerization. So your report contains, as usual, you have your cover page, your objective, introduction with a little bit of theoretical background, so you can talk about this heat of polymerization. Talk also on one of the things that you can talk about is on free radical polymerization, so that you can understand what it means. Your results and discussion, okay, conclusion, and what are the reference used in APA style. So this is due next week. Okay, so that's it for this experiment. Thank you, and assalamualaikum warahmatullahi wabarakatuh, and take care.